So good day guys, today we are looking at diagonalization method and we are given that x plus y equals 7 and 2x minus y equals 5. So the first thing we're going to do is we're going to rewrite in matrix form. Okay, rewrite in matrix form, and of course the matrix form you know is ax equals b. So we're going to have 2, 1, 2, negative 1. I'm sorry, 1, 1, 2, negative 1, because this is a 1, that's a 1, and that's a 1. So 1, 1, 2, negative 1 times xy equals 7, 5. Equals 7, 5. Now, we are using the diagonalization method. What does that mean? That means that we are going to take and we're going to multiply the adjoint of A times x equals the adjoint of A times B. So we're going to multiply the adjoint of A to both sides of the equation. And remember that the adjoint, to get the adjoint, we flip or we exchange A and D, and B and C, we change the sign. So since it is positive, we make it negative. So the adjoint for this A, which is 1, 1, 2, negative 1, its adjoint is negative 1, negative 1, negative 2, 1. And that times 1, 1, 2, negative 1 times xy equals negative 1, negative 1, negative 2, 1 times the result, which was 7, 5. So any questions up to there? We must multiply the adjoint to both sides of the equation. So this will contain a lot of matrix multiplication. So we continue. Negative 1 times 1. Let me write it here. So negative 1 times 1 plus negative 1 times 2. That is going to be our first term. Then the second term, negative 1 times 1 plus negative 1 times negative 1. The next at the bottom, negative 2 times 1 plus 1 times 2. And then negative 2 times 1 plus 1 times negative 1. And this I must multiply to the xy. Right? I must multiply that to the xy. And equals, I will have to multiply this out as well. So negative 1 times 7 minus 1 times 5, negative 2 times 7 plus 1 times 5. So there we have our next step. Notice I'm showing you every single step since this is the first example. When I go to the second example, I will be skipping some steps. Negative 1 times 1 is obviously negative 1. Negative 1 times 2 is negative 2. Negative 1 times 1 is negative 1. Negative 1 times negative 1 is a positive 1. Negative 2 times 1 is a negative 2. 1 times 2 is 2. Negative 1 times 1 is negative 2. 1 times negative 1 is negative 1. Times xy equals negative 1 times 7 is negative 7. Negative 1 times 5 is negative 5. Negative 2 times 7 is negative 14. Plus 1 times 5 is 5. Now, how can you tell if you're going correctly? You can tell because the leading diagonal must be the same number. So it must be what is called a scalar matrix. And the Non-leading diagonal should be zeros. If you don't have this, then you are wrong. So we're going to have negative 3, 0, 0, negative 3 times x, y equals negative 12 and negative 9. That is telling me, A, I'm going in the right direction. Okay? Now we're going to multiply negative 3 times x, that's negative 3x. Negative 3 times y, that's going to be negative 3y, because negative 3 times x is negative 3, 0 times y is 0, so I don't need to write it. 0 times x, 0, negative 3 times y, negative 3. And that is equal to negative 12, negative 9. Then I will equate the left-hand side to my right-hand side. So I'm going to have negative 3x equals negative 12, and negative 3y equals negative 9. Now that I have that, it should be obvious that I will be dividing by negative 3 on both sides for both of them. So here x will be 4, and here y will be 3. So x will be 4, and y will be 3.